project. We also have Justin Canada, our testing lead, as well as Marshall Brooks, our team leader and lead programmer. We've chosen to structure ourselves in extreme programming for the design process. Basically, so that we could adapt to changing needs as we are working on a research project with Dr. Envik, our client advisor. As well as to keep everybody caught up at all times. For collective code ownership, we have pairs programming constantly, as well as social networking. We're all very actively messaging each other about recent polls, pushes to the repository, checking that code regularly. We are using Bitbucket to host that. And then for adaptability, again, we are working on a research project involving the creation of recommenders, which I'll explain in a moment. And we want to be ready to adapt to any changes. We've already experienced quite a few in the user interface, the needs of the client. Some of the background on the project, recommenders in particular, is large projects just have too many developers to easily keep track of. And bug triaging becomes a huge problem because of that. You can't sit down, remember 50 names and every single skill set of every developer associated with them. So how do you triage that? The answer is a bug report assignment recommend, which uses machine learning to check out, basically make developer profiles, as well as classify bugs, and then recommend new developers who are qualified to work on a new bug report. So the real world problem we're trying to solve then is that these recommenders are difficult to create, it's a complex process, and it takes a lot of time. So to solve this, we intend to create a recommender creation assistant tool. And what this is going to do is it's going to allow somebody to easily create a recommender for any Bugzilla repository that uses XMLRPC, which is technology that lets us query their servers for information on all the bug reports. We'll be talking today about the project requirements, giving a short prototype demonstration, and then talking a little bit about the quality assurance on the project, and then we'll open the floor for questions.
So project requirements. We have three main things to consider with this. The efficiency of the recommender creation assistant, the flexibility of the assistant, as well as feedback which it could provide us as developers, so that way we can better improve the creation assistant. After all, it is a research project. So for efficiency, as of October 10th, the Firefox project has received just under 800,000 bug reports, which averages to about 300 bug reports a day. And obviously, bug triage takes a lot of time and a lot of resources for these large projects. Oftentimes, they have dedicated personnel just for assigning these bugs to different developers. What we want to do is make sure that this creation assistant has an interface which can be used by any team member due to their intimate knowledge of the project itself that they're working on, as well as the skills of their fellow developers. As such, we want to make sure that it's very intuitive to use and it doesn't need any sort of special training to use it. The recommender creation process must be intuitive. This will cut down on any sort of training necessary. Also, we want to make sure that the data is displayed efficiently and logically. We don't want to make the data hard to find and hide it behind some obscure menu option. And also, we want to make sure that's represented properly. If we could use a graph instead of a list, then we should obviously use a graph if it makes sense. We also want to make sure that we streamline this process. We don't want to spend half an hour creating each recommender if we could do the same thing in 5 minutes. On the other side of that, though, we don't want to be blacklisted by a server by querying it too often, which is a problem. We also want to make sure that it's flexible for any project. One way that we can do this is make sure that they have as much custom configurability of the creation assistant. This can be in the form of specifying the repository URL, so that way they're not restricted to, say, using Mozilla's trash repository. We also want to make sure that they're able to only consider the top contributors for bug reports. Sometimes you'll have a large project which can have 300 developers, but only the top 50 developers actually resolve bugs on a regular basis. We want to make sure that we consider only those top 50. And we also want to make sure that we only include bug types of a certain path group. And what I mean by path group is bugs tend to go through a life cycle. This can be such as assigned, fixed, reopened, fixed, resolved. We want to make sure that we can pick and choose which path groups we want to consider to increase the accuracy of the recommender itself. Here's a prototype of what we mean by we want to make sure that the data is prominently displayed. Up at the top left, it'll kind of give you a short summary of that recommender which has been created. In this case, it had pulled 1,000 bug reports from the date range of November 1st, 2012 to November 30th, 2012, with a sampling rate of weekly, so 1 day a week. And it found a total of 50 developers for that recommender. Up in the top right there, this isn't the graph that we plan on going for exactly, but we intend for it to be a graph where on the left side it will show the recall of the recommender. On the bottom it'll show the precision of the recommender as far as accuracy goes. And it'll be a line graph with each node representing a different bug report. And that way you could see which bug reports have been the most successful with the most accuracy and pull out that, or which recommender has been the most accurate, and pull up that recommender so that we could see which statistics or which options you chose. So that we could further tweak and try to find the best recommender for your project. Here we have kind of an example of what we're going to be doing for developer thresholds. You'll have a number of developers on a graph, and we'll have a slider which will allow you to choose the threshold of contribution. So say you want to set the threshold to 10% of all the bugs that have been submitted. It will get rid of any developer that has not resolved 10% of the total bug reports. And here we have a prototype of our configuration options for the pulling of data from a bug repository. So this could be URL, the login credentials, date range, sampling interval, and as well as sample size. One of the biggest things that we're going to be concerned with this creation assistant is the feedback that we receive as developers. As this is a research project, we want to make sure that we collect enough data so that way we can really optimize this assistant to be useful. The biggest question with this project is, are bug assignment recommenders practical in the real world? Or is it practical to create them? Is it too lengthy of a process? And to do that, we're going to be collecting usability data such as with surveys, user surveys, to see how satisfied they are with qualitative data. And we're also going to be taking quantitative data such as how long it takes them to create each recommender. Are they improving the accuracy with each recommender created, or are they losing accuracy, as well as how's their time creating the recommender improving? So that is our main focus when it comes to the requirements of this project.
Okay, so begin quality assurance. We start off with some testing strategies. Our code is in the very early stages. We're still trying to get our heads wrapped around the creation process. To start with integration testing, we are creating these UI modules individually and then kind of packaging them together to see how they work and how well they go on. For system testing, this will be finished when the backends near completion. We have a semi-functional user interface, as you saw, but I mean, a lot of the methods for the buttons don't quite work yet. Unit testing is going to be done using Visual Studio's built-in testing projects. We've looked at some other plugins, you could say, like NUnit. I haven't quite seen how those would be more effective than Visual Studio's built-in. So, risk management. Some of the major factors we have are the conversion of the Java product to the C# user interface and the C# backend. Getting a C# machine learning algorithm that works correctly. Some server overload problems, that's a big risk factor we have. And some minor factors are the limited documentation we have to all of these things. So some strategies we've developed to combat this. So for the conversion from Java to C#, we all need to make sure that we know both languages very well. We all know Java very well. We've all had experience in C#. We're doing a good job in getting that transferred over so far. We're also migrating the Java project piece by piece to C#, so we're not trying to do everything at once and just kind of break everything. We can just break things one at a time. Getting the C# machine learning algorithm, what we're doing there is we're trying to explore options. Right now we have one called libsvm, excuse me. We haven't seen any other machine learning algorithms, but that one looks like it should work just fine for us, but we're ready to explore options if need be. We also are trying to become more familiar with machine learning algorithms so that we can fix problems on our own that come up. To address the problem of server overload, I mean, make sure to read the API of all these things. Bugzilla has some API, and we're making sure to follow their rules for polling and searching. Also, we're trying to be overzealous with our polling. Every time we run our recommender, we are querying the server, and we don't need to pull 5,000 bugs every time. We plan on using a cache of recently loaded bugs so that we don't have to keep requesting the server when we're testing. Also, for the limited documentation problem, we're trying to be really innovative, try new things. It is a research project, and we're very excited about it. So, trying a lot of new things out here. And obviously, the internet is a great source, so there's lots of people who have probably tried to do this, so we're trying to look into that option too.
All right, and we'll conclude with a couple of lessons that we've learned while working on this research project thus far. As we said, a lot of limited documentation on all of our libraries and frankly everything. So we have to allocate more time for learning. A lot of our estimates have been pretty far off. We're probably not as far underway as we intended to be, but we've learned from it. We're going to be allocating more time to reach this learning curve. This particularly relates to things like XML-RPC, which we're using to do the pulls from the repository to get the bug reports from Firefox. And it's a slow-going process. Just installing the library took quite a while. We wound up having to do an automated process to install it. That C# was able to give us with a program called NuGet. Also, we need to do a better job confirming our conceptual model with our client. To begin with, actually, for the first probably month of the project, we were completely on different pages. the team and I thought that we were going to be using recommenders. We were going to be creating a recommender that worked with Firefox, and we wanted to display data from that recommender, like the recommended list. But what our client actually wanted was that we would be pulling from, creating the recommenders themselves. We wanted a UI that would simplify that process. So it's been a slow going process, and working on a research project has been really interesting, but it does come with its own associated risks. And any questions?
Can you clarify what will be input and output for machine learning algorithm?
So inputting, the input into this algorithm will be, to begin with, we'll have our bug reports, which we will pull from the Bugzilla server. And in those bug reports, we have the developer to which it was assigned. And we also have a description of the bug report. And the developer will become the label, and the description will be the instance. We'll feed those two elements into these machine learning algorithms, and that machine learning algorithm will take out all the stop words from the description and figure out what the key words are from the number of bug reports fed in, and associate those with individual developers. And from this, when you give it a new bug that you have, when you feed a new bug to this learned recommender, it will be able to tell you, okay, these developers match the keywords we found in this bug report, which you gave us.
What's the output parameter for machine learning? I still try to get it.
We're still wrapping our heads around it ourselves, to be honest.
The machine learning algorithm is actually going to be outputting the list of developers who are qualified to work on a new report. So we feed in new bug reports from Firefox that are unsolved, unfixed. And the machine learning algorithm would print out a list of names from the previous reports, our testing set, and say, these 5 developers are qualified to work on this report based on what they've worked on in the past.
Did you take machine learning to the data mining class?
No.
I recommend guys to be successful, you at least need to get minimum knowledge about it.
Absolutely.
Support vector machine is not working with the text, so to convert text to numbers, it will take time and knowledge to you.
I see another problem here. You will at the end come up with a recommender system which will normally work. How do you assess your result? In other words, how do you know that it's good?
We will determine this by measuring its precision and recall.
How do you measure this?
Well, precision is based off of, let's see if I can remember the equations off the top of my head.
No, don't tell me your formula.
Oh.
How do you assess? I mean,
Okay, so we will assess them by, we will have the recommender, which is trained, and we will have our testing set. So we'll have our training data, which we will use to train the machine learning algorithm, and we'll have the recommender, and we will have our testing set of bug reports. And what we'll do is we will give these this testing set of bug reports, which have already been solved, to the recommender, and see which developers it passes back as recommended. And using this, we could see if it was able to recommend all the developers which are capable for something like that.
At some point, using such a measure, like error measure, it doesn't matter what type of error it is, you will measure something between how many cases have been solved using your system, let's say. And then you come up with a precision like 10%. All right, now the next step is 10% enough? Is it good or is it bad?
Well, a lot of that tends to be the point of it being research in the first place. The purpose of this is to have a creation assistant so that we can create a number of recommenders and see at what point do you actually have a recommender which has the max accuracy. You can start off with your first recommender having a 5% accuracy rate, but you're not just going to be creating that one recommender. You're going to be creating dozens even to see how accurate you can make one, because the accuracy is specific to each individual project, and a lot of it is determined by how many bug reports you have available to even teach the recommender in the first place. So you may be, for instance, be able to reach a 60% precision rate with the Mozilla Firefox project. But the Mozilla Firefox project, as I found, has had 800,000 bug reports filed and solved. However, you can have a small project that has had maybe 8,000 bug reports over its lifetime. That will have nowhere near a 60% accuracy rate. So it's very specific to each individual project.
So the key thing here is it's a user interface tool that allows you to run a series of simulations and tweak parameters to see what can you get, or how close you can get.
Is this more like the trial and error process in this case?
It's a program for research. It's primarily for research. It's not for any real-world application. It's for case studies, really.
Actually, the short answer is yes. It's trial and error. Right? The client would say, okay, so the plan was create something with some default parameters. How good is that? Okay, now I'm going to change the threshold of developers. What does that give me? Is it better or worse? And the idea is, what we're trying to see, one of the questions is, how long does it actually take them to get to something they're happy with? Does it take a long time, or can they do it very quickly? Yeah. But you're right, it's trial and error.
Any other questions? Yes.
So you're saying, so you're developing this tool. Are there other tools out there that do similar things, or if you're trying to do it totally new, or if it's similar to others, how will it be better or different than those ones that are already?
There has been a lot of research in this, in the field of using recommenders for bug assignment. Have there been user interfaces created to assist in this process along the same lines as what we're doing? We're not sure. We haven't found any. So, yeah.
Why are you converting from Java to C#?
Well, we wanted to go with a C# user interface, and in the process of looking into pairing that with the existing Java backend, we found that in the long run it would be better to recode what was existing due to the ability to use .NET functionality on the backend, as well as the ability to clean up what the existing code and it just work on its readability a little bit.
And we're also interested in the project. We just want to learn a little bit about XML RPC, things that kind of lesser known APIs, as well as machine learning, which none of us have had a lot of experience with. And again, there's a big learning curve associated with it, but we're meeting the learning curve pretty much head on and really finding out a lot and having quite a bit of success. We haven't hit the machine learning side of it quite yet, but we are pulling from repositories and are able to gain bug report data through our XML RPC library.
So is C# only available on PC? Or can somebody on Macintosh run this?
I would assume that in order to run it on a Macintosh, you would need to use a emulator of some sort.
I could actually fill that in. There's an open source project called Mono to implement all the C# functionality. It's fairly complete now, but there's some rough edges.
Great.
I have run the C# project on my laptop that runs Ubuntu, so it at least compiles. I haven't tried to bring up the interface or anything, but I can build the solution. So we talked about the cross-platform problem. It didn't seem like it wouldn't be a problem to the client. At least at this point, it's really for just research. We're just trying to see if we can do it.
It's just interesting that the open source projects that use like Zilla bug report repositories, the ones I've played with are Java hoses. And so you're going to write a C# program to help out Java hoses.
What we've found thus far, actually, I'm sorry.
Well, this won't be interacting directly with any other program. That's the thing. We're just using an XML RPC protocol to retrieve these bug reports from a Bugzilla server, and the server doesn't care what language we're calling it from. So that won't cause any sort of problems.
And to be on the more technical side, actually, it's proved simpler so far. Our XML RPC calls, whereas in Java would return hash sets, things like that, we're getting instead structs. So structures that are just a little easier to use than a hash set, at least in our opinions. And we can pull directly to specific fields. So if we only want the identification field and the assigned to field and a summary of a bug report, we can take those three and nothing else. And our query will return those three. We can print them, place them in our algorithm, whatever we like. So far it's been a good process with XML RPC and has looked simpler than our Java counterpart code.
Yeah.
So you say that you're doing this conversion from Java to C#, and I'm catching several keywords. You're saying that it's a steep learning curve, it's difficult, there's still some things you don't understand. So this conversion from one language to another, and you also said that you're going to be cleaning up the code. So I don't know how this code works, but what happens if you can't wrap your head around it? What happens after 3 months you haven't been able to learn this Java? Because it might be the case that the code that you're trying to convert into C# was written by 10 developers over 2 years. So what happens if in 3 months or in 4 months or in 5 months you're not where you want to be? Because that's a possibility, right?
Well, the nice thing about what we're doing actually is that we're not so much converting it as much as rewriting it using the existing code as documentation of sorts. So if we do run into a roadblock, we just go and look at the Java, see what was done there, almost as if it's pseudocode. It's almost more paraphrasing than converting.
And fortunately, our client has built a few recommenders and has quite a bit of experience with these projects. So we have a mentor on this project, and we're fortunate for that. But it would be an issue to run into that. Though so far we're confident, we've learned a lot. Again, we've got the XML RPC side down, so at this point it's getting to be more of a question of the libsvm library and whether we can learn that. So
The project was also mainly about creating just the UI for the developer. If for some reason we can't get that recommender backend to go in C#, we can always just fall back to, well, we can just create a C# interface that somehow plays with the Java recommender that works just fine. So that we can always fall back to that, which we can do. I mean, we've already got.
We have a backup plan for that.
Yeah,
So that's your answer, yes.
Yes,
Perfect.
exactly.
Okay,
Yes.
great.
Thank you.
Thank you.